Michael, thank you so much for joining us on MoloMolo African Tech Stories. It's really a privilege to be able to speak with you today. Maybe we can start by just who you are and essentially what is your journey up to now has been in terms of system engineering.
Well, hello. Thanks for having me here. It's a pleasure to be here. I'll try to make it short. I've always been super excited about software engineering, and I was lucky enough to be there at a time where things just started to explode. And I was also lucky enough that, due to family circumstances, I decided to study engineering. So I'm actually an educated naval architect. Ocean engineering is what I studied. So I learned how to build ships. And the ship is something that represents a very complex system where you have everything from hydraulics, electronics, and many other disciplines. So it was like a very good and broad foundation for being a systems engineer. I worked as a software engineer, went to software architecture, eventually came to requirements management and then systems engineering. Spent some of the time in the US at startups. I was always very entrepreneurial and eventually ended up founding my own company after finishing my PhD in requirements modeling and have been independent ever since. And it's a very exciting field to be in.
Amazing. You are definitely my idol. I think we are meeting here in Austria, which is first of all my first time here in Kalmkirchen. I've passed through Austria. I've never really kind of actually stayed even one night in Austria. So I'm really excited. I think the one thing that strikes me the first time we met is just how open and willing to discuss different topics you are. Where did that transition from an engineer to kind of wanting to teach about system engineering? Where did that come from?
I think a lot comes from having grown up with software because many of the ideas about openness, about sharing comes from the software industry, where once you create some software, sharing it is essentially free of charge. You have to write it once and you can distribute it. That's one aspect. So I think it's very cool to share. If it doesn't cost you anything, it's very easy. The other thing is that it has many benefits for the world, obviously also for myself to share my knowledge. But we are living in a world where things are incredibly complex. And typically, if you give something away like knowledge, that typically comes back to you at some point. And I think the software industry shows this very dramatically, where software tools, programming languages, libraries, so much of the stuff is free. That doesn't mean that there isn't a business model behind it. Of course, there's a business model. You have to pay for all the things. But I find it very interesting how much progress we did in software engineering by providing open platforms that allow people to collaborate. And there is plenty of space for building a business model, for earning money. And this is one of the things that I really would like to see more in the systems engineering world or the world of product development. And as a side note, we are starting to see that some of the more hardware-oriented tools start to be free. One of my favorite examples, that's not an endorsement, is Onshape from PTC, which is free of use. It's a parametric computer-aided design software that is free of use if you keep your designs open. And that's the same thing that GitHub did initially.
Correct.
And I think it clearly shows that by finding a business model and a way to open up is a huge enabler.
Amazing. I think that is such an important point that you make. The openness focus. The focus on being open. The focus on knowing that open doesn't mean free. For you not having anything, right? Essentially, that's what you mean.
Yeah, exactly. We all have to make a living somehow, but there is the possibility for doing that.
Oh, wow. And I guess so basically MBSE, um, maybe you can give us a bit of what does MBSE stand for? What does it mean to you? And how does basically what you founded kind of connect it all in your mind?
So I really like to take the term apart, model-based systems engineering. So let's start with systems engineering, something that we started in the 60s when we started to build rockets and reliable complex systems. To me, the core of systems engineering is the V model. And I find that the V model is often misunderstood because some people see it as a process. And if you see it as a process, it feels like it's like a waterfall with some testing, and that's just not true. But I really like to look at the V model as the connection, the traceability between artifacts, requirements, implementation, and testing. And this creates like a very robust triangular relationship. If your test fails, that either means you didn't fulfill your requirement, you didn't create a proper test, or your implementation is buggy. But you always have like this triangular relationship that provides stability. So that's the systems engineering. In the beginning, they did that with documents, and that's where the model based comes in, where we create formal or semi formal models that can, where you have like traceability that goes beyond something that can be tested by a human. And that again um, is an enabler for scale and speed. In practice, however, and I think this is very sad, it's very often the opposite because it's often used simply to fulfill compliance. But I see huge potential there for really transforming product development.
Oh, that's amazing. I mean, the one thing that I'm very grateful for is basically your knowledge and your expertise on it, but also the fact that you see the positive side of the implementation beyond just the compliance and more the a mindset. And I guess maybe that goes with my question regarding formal minds. Where does that fit in into kind of this ecosystem?
Yeah, that's an interesting question because again, it's a small company. So the name stems from the fact that we need some kind of formality or formal modeling for mastering complexity. So this is basically for me the core issue that thanks to software networking, the complexity of products is simply exploding. Self-driving cars, drones that autonomously perform all kinds of sophisticated actions. That's a complexity that we've never seen before. And we need to differentiate between complexity, which happens when you have many, many parts interact loosely, and complicated system, which is deterministic. So typically you'd say that a complex system is not completely deterministic. So I see that as an enabler. And so just to close the circle, formal mind expresses this idea that you need this level of formality for mastering the complexity of modern products.
Yeah, I mean that is definitely needed because I think it's such a difficult thing to go from one client or one system or one company to the next and just see how the concept of system engineering is vastly different, and the formality in how you communicate is almost, you know, up to someone's view and not so much a consistent way of talking, right?
The question is whether that's a good thing or not. And again, if we look at software development, there was a lot of experimentation in the 2000s, in the 1990s, until we finally figured out a way that has a certain stability or robustness. And of course, you need to adapt based on the product, based on the team, based on compliance requirements, and many other things. But at least to me, it feels like in software engineering, we have this toolbox, and it's fairly straightforward to grab the right pieces. So, for example, if you build a web application, uh, th- they're fairly they're best practices that guide your architecture and your implementation. If you're developing a game or an operating system or an embedded system, there are already best practices around that allow you to get started fairly quickly. But again, in software development, we have like lots, we have a single source of truth by having text-based code and unit tests and all these artifacts in a tightly bundled system and with loosely coupled components. All that is missing in systems engineering, partly because the companies that build complex products are very protective of their IP, and that's understandable. But at the same time, in order to stay competitive in the world, I believe that we need to find a good balance, a good compromise on opening up certain things and allow collaboration and provide tools that support team members to do that, while at the same time allowing companies to maintain the integrity of their IP.
Yeah. I think so. This is your last point is very important because I think of the balance between time, but also development cost that you're trying to recover by keeping things closed, but also lack of understanding of what can be open and open to collaboration. And I guess the next question I have for you is just in terms of the tools that are out there and what you are aware of, how can tools and tool ecosystems really support such conversations for a startup today that says, yeah, I want to be, this is my idea and my idea is so important because the investors have invested and I cannot afford to open for scrutiny or open for collaboration at the risk of basically causing this idea to be taken by someone. How can a tool or conversation help with that?
I think a conversation is more important than the tooling. Tools are part of the solution, but the real problem is mindset. And that's a huge issue. You really have to make decision makers understand the value of communication. And again, even the best tools will not help you if departments, for example, feel the need to protect the turf and if communication between departments is blocked. There are many tools. I mean, any new tool entering the market provides collaboration features that really allow you to collaborate in a way that that speeds up things dramatically. But I also know that there are many teams that reject them.
Yeah.
And so history is a problem. People tend to reject any kind of change. That's a huge problem, especially for established players. So yeah, I think tools are an important puzzle piece, but only a puzzle piece. And I build, like, my personal opinion is, and I'm not talking about Germany and Europe and uh, Germany in particular, I think we need many more startups because I think change can only come if you're questioning the status quo. And I think it's very difficult to do that from the context of an established player.
Yeah. Yeah. And I think that really leads me to the next question regarding kind of MBSE, system engineering in general, the tools that goes with it, and AI and the digitization that goes with it. Where do you see that going within that conversation of openness, but also the impact that potentially AI can have in either amplifying or helping those conversations to people to adopt, or potentially seeing the dangers that AI can bring?
Yeah. And I mean, you know that at the MBSE summit tomorrow, that's exactly the open space session that I'm going to moderate. I find it very dangerous to put AI first. AI to me is an enabling technology that will stay around, like the internet, like electricity, like many other enabling capabilities. And therefore, I think that we really need to start turning the question around not asking how can I build a better product development on top of AI, but more the other way around. Where are my problems in product development, and how can AI support me with these activities? And a specific example is MBSE is often criticized for being too complicated, for difficult for people to actually properly use. And AI might be an enabler of making it accessible, where you have, for example, a modeling assistant that where you explain what you want to do, and the assistant helps you doing that. Specifically, modeling is like programming. There are so many different ways of doing something, and there's no right or wrong. There's just better or worse. That's why we have best practices in software development. That's why we have design patterns. And 20 years ago, we had to learn them and apply them. And AI can help us do that without having like the deep modeling experience.
I mean, this is thanks for giving me that point, because I agree with you. I do agree that AI can help us solve the problem and not so much be an additional feature
Yes.
to a already complicated solution, which might potentially drive us away from the conversation, which is how do we adopt MBSE better in traditional ways. I guess the last question I have for you is, given your influence and where you are at, what are some of the pitfalls or advice you have for younger, more enthusiastic engineers who really want to get into MBSE based way of thinking, but also get into that conversation regarding thinking more systems and not just silos within your. What are some things that an engineer can do towards getting to that point?
And that's a great question. One of the big problems is that typically kids go to university and they want to study automotive engineering or aerospace engineering and so forth. And that's fine and good. There are courses for systems engineering, and these days most courses actually include at least a semester course on systems engineering, and that already helps creating like the right mindset. The challenge with systems engineering in general and model-based systems engineering in particular is that systems engineering per definition is cross-disciplinary. And without the real experience, having soldered something together, having written some code, having been in the workshop, it's it's all very abstract. So systems engineering is something that really starts to make sense once you collect some experience. And so back to your question. So number one is and this goes beyond MBSE, continuous learning. I think this is more important than ever. You need to learn your whole life. Otherwise, you'll be basically quickly disposable, unfortunately. The other thing is, this is again a very, very personal choice. Um, if you enjoy what you're doing, it's much easier to being good at that. And so, really think very hard what you feel happy doing 8 hours a day, if you could do that. And again, this is more often associated with other professions like being a lawyer or a doctor, because people think, oh, yeah, that way I will be rich or I will be, famous or anything like that. Don't think about what you want to be, but think about what you want to do. And if you enjoy programming, by all means, find a job where you program. If you enjoy enabling and talking to people or teaching, then do that. And systems engineering provides you a platform, if that's what you want to do, for all these activities. Systems engineering is very much about people, but it's also very much about enablement, which can be very technical. And so, but again, generally, my advice is, and this is completely independent from MBSE, we are living in a time that is changing so fast that do something that you enjoy doing and don't stop ever learning.
Mm. Stephen, thank you so much for this time. This has been a really great conversation. I'm really so happy that you've made the time and the effort to make the space for us to have this conversation here at the conference. Thanks again. Hopefully, this is one of many. Who knows? We might meet again. Thanks again for coming to the show.
I expect to meet again. Thank you for having me.
Great. So there you have it. An amazing conversation with Michael, and it was just such an amazing time where he basically gave us such a insight into what it means to be a system engineer, what it means to really think about people, not think about the tool, not think about what can I give, but how do I feel about what am I doing. This is another episode of MoloMolo African Tech Stories. I'm Dr. VK. Until next time, ciao.